Today we are going to solve systems of equations using substitution. We've already solved systems of equations by graphing, and now we are just going to use algebra to actually substitute our equations to find our coordinate point. This is still finding the point of intersection, it's just we're not going to actually draw the graphs. So when using substitution, we are literally going to do just that. We are going to substitute a value in for another value. So on this first example, we have x equals 3. And then we have y equals 2x minus 1. Those are our two equations. Since we already know that x is 3, our answer should have a coordinate that starts at the value of 3 for x. So all we are going to do here is plug in 3 for our x. We are going to substitute. This x equals 3 is the same x as down here. It's the same letter. So this becomes y equals 2 times 3 minus 1. So y is 6 minus 1, which is 5. So my answer here would be 3, 5. Now you can check every single time on these equations. So here we get x equals 3, x is 3, so that one works. For y equals 2x minus 1, we have 5 equals 2 times 3 minus 1. So 5 equals 5. So that one works as well. Now, when you use substitution, your equations could also look something like this. Here, y equals x plus 2. It's still the same y as down here in the 3x minus 5y equals 10. It's just now it's not just one number, it's an equation. We are going to plug in this whole equation, x plus 2, in for our y on the second equation. By doing so, we will have one variable on this equation. So this becomes 3x minus 5 times x plus 2 equals 10. It's very important to write this in parentheses, what you're substituting in, because when we solve this, we have to distribute the 5 to both the x and the 2. So when we solve this out, this becomes 3x minus 5x. Negative 5 times x gave me negative 5x. Negative 5 times 2 gives me negative 10 equals 10. And so now we're just going to solve this for x. 3x minus 5x, combining like terms, is negative 2x minus 10 equals 10. And then to solve for x, I'm going to add the 10 over. We have negative 2x equals 20. Divide by negative 2. X is negative 10. So we have the first part of our answer. We know our x value. But now we need to find our y value. So we are going to substitute again to find y right here. If y equals x plus 2, and I know x is negative 10, then like we did on the first example, I'm going to plug in negative 10 for x here. We get y equals negative 10 plus 2. So y is negative 8. And just like on the first example, we can check both of these. I should be able to plug in the point and it should work for both equations. So for y equals x plus 2, we get negative 8 equals negative 10 plus 2, which is true. And for our second equation, I'm going to number them. For our second equation, we have 3x minus 5y equals 10. So 3 times negative 10 minus 5 times negative 8 should give me positive 10. Negative 30. Negative 5 times negative 8 gives us positive 40 equals positive 10. So it works for both of them. You should check every single time you do these. Now let's do one more example. I have y equals 2x minus 5 and then 2x minus 4y equals 14. So my first step is to substitute what we already know. I know that y equals 2x minus 5. So when I plug this in, I have 2x minus 4 times 2x minus 5, don't forget your parentheses, equals 14. So this becomes, once I distribute, 2x Negative 4 times 2x is negative 8x. Negative 4 times negative 5 is positive 20 equals 14. Combine like terms, we get negative 6x plus 20 equals 14. Subtract the 20 over. We have negative 6x equals negative 6. Divide by negative 6. And negative 6 divided by negative 6 gives me a positive 1. So we have our first variable. We have 1 for x. And now I need to find my second variable. So we have y equals 2x minus 5, and I know that x equals 1. So plugging that in, we get y equals 2 times 1 minus 5. So y equals 2 minus 5, which is negative 3. And you guessed it, we are going to check every time. I'm going to plug my coordinate point into both equations because it has to work for both. This is not my answer if it works for one equation but not the other. So for y equals 2x minus 5, we get negative 3 equals 2 times 1 minus 5. Negative 3 equals 2 minus 5, which is true. And for my second equation, we have 2x minus 4y equals 14. So 2 times 1 minus 4 times negative 3 equals 14. And negative 4 times negative 3 gives me positive 12 equals 14, which is also true. Now, your assignment for this video is to solve this one on your own, and in your notes you need to write down the coordinate point that you get. Make sure you check it, and this is what you will show me.